Now, so let us look at few more results on how to measure. So the first one is a corollary. So if A is countable, then N star of A is equal to 0. So let us see the proof of this result. A countable ആണെങ്കിൽ we can always find a sequence of distinct terms such that A is equal to the particular sequence. So we know that every countable set can be expressed as a sequence of distinct terms, expressed as a sequence of distinct terms. And so we may assume so that A be equal to this sequence Xn where the Xn's are distinct. Now, by the countable subadditive properties in last class we have seen the countable subadditive property. So by countable subadditive property, so when we take n star of A, n star of A will be equal to, so A will be, A will be union of all this singleton sets Xn, n is equal to 1 to infinity. So n star of A will be equal to n star of union n equal to 1 to infinity, a singleton set Xn. Now by countable subadditive property, this will be less than or equal to summation. So we'll get less than or equal to summation n star of singleton set Xn. Now for a singleton set, the measure will be equal to 0. So length of the set will be equal to 0. So it will be summation 1 to infinity, up here you will get 1 to infinity. So the n star of singleton set Xn will be 0, so X will be equal to 0. So therefore we will get n star of A less than or equal to 0, but we know that n star of A is greater than or equal to 0. So combining both, we will get n star of A is equal to 0. So if A is a countable set, then that's how the measure will be equal to 0. And next, the result we are going to see. So the next result is, so we can actually, we will n star countable subadditive. So again, n star is finitely subadditive. Finitely subadditive means, so if you are taking n star of union, so k equal to 1 to n, take it. So you are having a finite number of sets. So this will be less than or equal to summation n star of each ak. For countable subadditive, so here we have k equal to 1 to infinity ak, that will be less than or equal to summation 1 to infinity n star of ak. So here you have a finite number of sets. So again, the proof of finite subadditivity is again by using countable subadditive property of n star. Okay. So let us consider finite number of sets, say A1, A2, an, A1, E2, An are n sets. Now define ak to be equal to 5 when k is greater than n. So we have the sets an plus 1, an plus 2, so on. So all of them are 5. Now let us look at union k equal to 1 to infinity ak. So that will be union k equal to 1 to n ak union union k equal to n plus 1 to infinity a. Now this will be the empty set. Now let us use the countable subadditive property. So therefore n star of union k equal to 1 to n ak will be equal to n star of union k equal to 1 to infinity ak. കാരണം ഈ രണ്ട് സെറ്റ്സും സെയിം ആണ്. So their outer measures will be the same. Now by countable subadditive property, so n star of union k equal to 1 to infinity ak will be less than or equal to summation n star ak. So we can split this as summation k equal to 1 to n n star ak plus summation k equal to n plus 1 to infinity n star a. Now this will be summation k equal to 1 to n n star ak plus the 0 ആയിരിക്കും വരുന്നത്. So since this is n star 5, n star 5 will be equal to 0. So therefore we will get n star of union k equal to 1 to n ak less than or equal to summation k equal to 1 to n summation k equal to 1 to n n star of a. So that is the property that n star is finite subadditive. So let us look at the next result. So the next result is the outer measure of any finite set. If you have a finite set, then the outer measure of finite set is 0. Again, for the proof, we will use the finite subadditivity of n star. So let us consider the finite set A equal to the set x1, x2, etc. xn is any finite set. So A can be put in the form union k equal to 1 to n x k. So therefore n star of A will be equal to n star of union k equal to 1 to n all the singleton sets, union of all the singleton sets xk. Now by finite subadditivity, so this will be less than or equal to summation k equal to 1 to n n star of each xk. So this is by finite subadditivity. And now n star of xk will be 0 for a singleton set, measure will be 0. So that will be equal to summation k equal to 1 to n 0. So n star of A is less than or equal to 0, but we know that n star of A will be greater than or equal to 0. So therefore n star of A will be equal to 0. So therefore the outer measure of a finite set will be equal to so therefore we can say that when you take the set of natural numbers, the set of rationals, and when you take the set of integers, already kandu. So when you are taking a countable set, the outer measure is equal to 0. So we can conclude from all these results that so when you take n star of n, n star of q, n star of z, so all of them are equal to z. Again by this result, if you have a say a finite set A equal to the set 1, 2, 3, so this is the finite set. So in this case n star of A will be equal to 0. So if you have a countable set or if you have a finite set, then the outer measure will be equal to 0. So let us see a problem. So show that the set closed interval 0, 1 is uncountable. So we will use the concept of outer measure to show that the set 0, 1 is uncountable. So let us look at the proof of the result. Now let us assume by contradiction that the interval 0, 1 is countable. So suppose that closed interval 0, 1 is countable. So countable anengil, as we have seen, its outer measure will be equal to 0. So if A is countable, then we have already shown that m star of A will be equal to 0. So therefore m star of closed interval 0, 1 will be equal to 0. ഇനി closed interval 0, 1 എന്ന് പറയുന്ന interval ആണ്. Now we have seen that for an interval the outer measure will be equal to length of the interval. So m star of 0, 1 will be equal to length of closed interval 0, 1. So the length of an interval will be endpoints in the difference theorem. So length will be equal to 1, which is not equal to 0. So therefore we get the contradiction. So therefore our assumption is wrong. Therefore closed interval 0, 1 is uncountable. So using the outer measure, we can show that closed interval 0, 1 is